Welcome to Module 16 on function rules. Go ahead and get your notebook out so that you can take notes. Remember, you can use your notes on the quizzes, and you definitely don't want to try to rewatch all these videos when you're trying to do the lesson. Today's module is Module 16, so turn to a new page in your notebook, write Module 16 on function rules. We're going to mostly be focusing on function tables today, and how to use function tables and how to create them yourself. So you want a new topic, function tables. And we want to remember that an equation is just a set of steps that we use to calculate an output based on an input. Your input are your x values, your output are your y values. So I would definitely write this vocab down here. When they ask you to fill in the table using the function rule, that's just fancy words for use the equation. So the equation tells you that you're supposed to multiply 3 times x and then subtract 5 every time. All we're going to do is substitute in. So every time we're going to replace x with whatever x is equal to. So in this case, x is equal to 2. So this becomes 3 times 2, which is 6, and 6 minus 5, which is 1. So my output for that one is 1. For the next one, it's 3 times 3, which is 9, and 9 minus 5, which is 4. Notice I'm using my order of operations. Multiplication always comes before subtraction. For the next one, 3 times 9 minus 5. 3 times 9 is 27. 27 minus 5 is 22. And for the last one, 3 times 10 minus 5. 3 times 10 is 30, and 30 minus 5 is 25. And that's it. You pause the video and try this one on your own. Notice that this should be 3 plus 3 times x, and we always multiply first before we add. So when you do your first one, it should be 3 plus 3 times 3. You don't do 3 plus 3 first and get 6. You do 3 times 3 first and get 9. So that should become 3 plus 9. You finish that and fill in the rest of the table on your own. You should have added 3 and 9 for that one and gotten 12. And then let's finish the rest together. So that's 3 plus 3 times 8. Well, 3 times 8 is 24, and 24 plus 3 is 27. For this one, it's 3 plus 3 times 9. 3 times 9 is 27. 27 plus 3 is 30. And 3 plus 3 times 10. 3 times 10 is 30. 30 plus 3 is 33. Order of operations are always a rule. All right, new topic. We can do the reverse of this and write our own function rule based on a table. So we're going to keep these pretty simple for right now until we get into slopes later on. So we're going to create our own function rule using the table. You want to look at how the input changes when we get the output. So there's two things that could be happening here. 6 and 3 are paired together. We could either be subtracting 3 because 6 minus 3 is 3, or we could be dividing by 2. If the number gets smaller, that means we're either subtracting or dividing. So we want to see how this stays consistent as we go across the table. 8 minus 3 is 5. 9 minus 3 is 6. It looks like the rule is to subtract 3, not divide by 2. Now, the way to write a rule for that is to just take your input and do whatever the operation is to it. So the function rule for that one is n minus 3. You pause the video and try this one on your own. You should have noticed for this one that you can either add 2 or multiply by 3. You can't just look at one set though, because we don't know which one of these is accurate. 6 plus 2 would be 8. 6 times 3 would be 18. 7 plus 2 would be 9, but 7 times 3 would be 21. So it looks like times 3 is the rule. You could have written this a couple different ways. You could write it as n times 3. You could write it as n dot 3, or you could write it as 3n. Do a better times there. Any of those three answers would be correct. Instead of filling in the table, we might be asked to verify solutions. So I want you to, new topic, identifying solutions to a linear equation. And then what we're doing is just checking this. So what they're giving you is an input and an output. They're telling you that -4 is your input, 18 is your output, and you want to see if that's correct for this equation. So we're going to substitute in. 18 is y, x is -4, and we're subtracting 6. We're going to use our order of operations. 3 times -4 is -12. Negative 12 minus 6 is negative 18. And you want to be real careful. Positive 18 and negative 18 are not the same thing. If I owe you $18, that's different than if I have $18. So we would say no for that. So then we keep trying. For 5 and 24, this becomes 24, because I put the y where the y goes in the equation, equals 3 times x is 5 minus 6. 3 times 5 is 15. 15 minus 6 is 9. Those do not match, so we say no. Negative 30 equals 3 times negative 8 minus 6. Well, let's see if that equals negative 30. 3 times 8 is negative 24. Negative 24 minus 6 is negative 30, so we say yes for that one. And for the last one, negative 45 equals 3 times 7 minus 6. Negative 45 equals 21 minus 6. Negative 45 equals 15. That one's a no, so we would say no for that one. It is also possible to get a whole table full of yeses or a whole table full of no's. You don't just have to have one yes, and you don't have to have any yeses. So don't be scared if you get all no's. You might want to double check your work because it doesn't happen very often, but it does happen. You pause the video and try this one on your own. Welcome back. You should have replaced x with 4 and y with negative 1 for this first one. So x is 4, y is negative 1, and that equals 19. 3 times 4 is 12. Negative 7 times negative 1 is positive 7, so be careful about your signs. 12 plus 7 is 19, so we say yes for that one. Just because that first one is a yes doesn't mean that we're done. There are an infinite number of points on any straight line, so we need to keep going because there are others of these that could be yes. For the next one, it's 3 times 5 minus 7 times 6, and we want to see if that equals 19. 3 times 5 is 15. 7 times 6 is 42. 15 minus 42 is going to give me a negative number, so I already know my answer is no, but let's go ahead and double check. 15 minus 42 is negative 27, and that definitely does not equal 19, so we would say no for that one. For this one, 3 times negative 3 minus 7 times negative 4, we want to see if that equals 19. So we have negative 9 here. Negative 7 times negative 4 is positive 28, so we need to add 28. And negative 9 plus 28 is 19. So here's a perfect example of a time where there are two yeses. It's possible to have more than one solution. And for the last one, 3 times negative 8 minus 7 times 2, we want to see if that equals 19. 3 times negative 8 is negative 24. Negative 7 times 2 is negative 14. Negative 24 minus 14 is negative 38, and that does not equal 19, so you should have said no on that one. And you're done. This was a short module today. You should make sure you've taken all your notes from this video. Then you're going to want to log into ALEKS and select Continue My Path and do your Module 16 practice problems. If you have not yet done Modules 1 through 15, it will not let you get to Module 16 until you do those first. While you're in ALEKS working on the practice problems, just click on the explanation to get some extra help. And when you've done all the practice problems, then you'll go to Assignments and take Quiz 16. Have a great day.